No, pass it. Now you don't record it. That only I am.
Sorry. Dr. John has made a significant contributions through published books on statistics for economics and business statistics as per the NEP syllabus, and through a range of impactful research publications in reputed journals. He is also actively involved in minor research project funded by UGC, exploring the intersection of culture and the healthcare. Dr. John's roles extend into administrative and developmental spheres at St. Aloysius deemed to be university. He has coordinated numerous cells such as International Collaboration Cell, Employability Skills courses, Youth Red Cross and Students Internship. He is also a co-founder of two consultancy firms, Oikos Statistical Consultancy and Tech Growth Academy, and is developing a new initiative, MediStalent Solutions, emphasizing his entrepreneurial spirit and dedication to applied economics and healthcare. We welcome you, sir. Now we are just overing it to you. Please start the session, sir.
Thank you so much, ma'am. Am I audible?
Yes, sir.
Okay. Thank you so much. And thank you, Krista Jayanti College, for inviting me for the today's for the talk. That is basically we are focusing on data analysis and visualization. I want to share the screen, but I'm not able to. Host should allow me.
Yes, sir. Now you can share a screen, sir.
You can see the screen?
Yes, sir.
Yeah. So you can see the screen, right?
Yes, sir.
Yeah. So we are going to discuss on AI tools for data analysis and visualization. Without directly, let us focus on what are the things that we are going to discuss. The first thing will be we are going to give an introduction for Jamovi. Then I have already given a PDF file where you might have seen how to install Jamovi. It is optional, but then too I will just show in Google what we are supposed to do. And the next is we are going to understand Jamovi software. Then we will be focusing on how to do the analysis, that is especially descriptive statistics. Just in 5 minutes, I'll try to show not all, but then to the basic things I can actually show. Then we will also discuss about three things, chi-square, regression, when multiple regression model I'll be showing. At the same time, meta-analysis. And also few things like how to get these add-ons from the library in the Jamovi, that is StatCat, learning statistics through Jamovi and meta-analysis. And there are few tools which we call it as visualization tools, AI tools. I think the first session I've heard where the professor had mentioned about Julius tool. So I had planned in my mind, like, no, I will show it that tool. But anyways, sir has mentioned, so I'm not going to touch that. We're going to discuss on a tool called Akio, which is actually data analysis tool, and also one more tool, Flourish.ai, which is a visualization. Hope all these things are very clear. And with this background, let us start. Am I audible?
Yes, sir.
Yeah. So the first thing is we have to check Jamovi, how we have to install Jamovi, just you have to go to Google, just type Jamovi, Jamovi. And the moment you type Jamovi, the first option will come, that is Jamovi, which is open statistical software for desktop and cloud. Then just click that. When you click, so you'll be getting this option, this dashboard, where you will have Jamovi desktop, where two options will be there. One is solid, another one is current. And before going to that, let us understand what are the features of Jamovi. One is Jamovi, it helps for analysis, and also it helps for statistical spreadsheet. And we also should understand Jamovi, the backend software is R. So in case if you know R, you can actually use the syntax to run the answer in Jamovi. Some no papers, they are actually syntax they ask. So you can actually get the syntax from Jamovi as well. And you also have other options like teaching, community, then create your own idea. All these options are available. So when you open Jamovi, you will get two options. One is solid, another one is current. So I recommend you go for a solid. Current is something where in Jamovi software, there are many researchers or statisticians who are working and they are trying to update. And also they are trying to come up with their own add-ons, which will be reflecting in the library. So in case if you're using current version, you will be getting the latest features. But solid is better because already everything is tested and it is there, right? So you can download solid or current and you just download the software. Then once it's downloaded, once you install it, then just go to the Windows, just type Jamovi, and you will get like this. And double click Jamovi, you will be getting the software. Okay, you will be getting the software. So directly let us go to the software. So once you download the software, once you install the software, you will have like this. You will be having a ribbons like variable, data, analysis, and edit. So if you click variable, you'll be getting analysis, you'll be getting all these options. So what is the difference between Jamovi and other SPSS software? SPSS also is a menu-driven software. Jamovi is also a menu-driven software. The advantage is Jamovi is a free software. Okay, there are add-ons which we may have to pay, but it's a completely free software, and therefore you can see more number of research scholars and also teachers who are teaching statistics. They are switching from SPSS to Jamovi because it's a free open software. Whereas SPSS, the version keeps on changing, and whenever the new version is there, you may have to pay a amount. And the second difference in Jamovi, when you compare with SPSS, SPSS is having two windows. So one is a data entry window, another one is a analysis window. And whatever the output it comes, again, it will go to the third window. Here, you don't have anything. It will be one window only. So whatever the data you are entering, it will be here. Whatever the results you are getting, it will be on the right side. And also it's user friendly. You can drag like this and you can adjust the screen. Okay, all those things that you can actually do it. So when you open this Jamovi software, just click on data. And what you can do is, let us take, we want to type a variable. So what I will do is, I will just double click here and I will just type, let us take, when you double click on the first column, you will get this dashboard and just type height. Okay, height. Or maybe weight also you can type. Okay, so height. So what exactly the measure type that you can decide? What is a measure type? Height is a continuous. You can select continuous. Then what is the data type? You can actually decide, okay, whether it is integer, decimal, text. These are all these things which is there. So once it is done, so you have a variable here and you can keep on typing the numbers. Okay, keep on typing the numbers. So you have variable. Then let us take, you want to select one more variable. Just double click and type gender, and just type the gender measure type as nominal. And if you really want to type it as a text, you type text, and you can actually write here male, then female. So it goes on. So all these options are available in Jamovi where you can actually type the variable. So if you really don't want this, you just click here and delete the variable. Okay. And otherwise you can here also you can click and delete the variables. So this is how it is. So if you really want to add the variables, you can add the variables. You really want to delete the variables, you can delete as well. Now, let us take the first example. What I will do is already Excel sheets already we have forwarded. Hope it's there with you. Yes, no, ma'am?
Yes, sir. Yes, sir.
So what you have to do is first you download all the Excel sheets. Then what you do is just click on open. Okay. Then you click browse. Then you have a sheet. So which sheet you have to select? You select HDI final. Just select HDI final and click open. Okay, click open. So the moment you click open, so you will get like this. So all the variables like country, population growth, Gini, right? If you don't want to see this way, you can actually click variable and you can see all the variables like this. Okay. So now let us take, you have a variable already has been there in Jamovi. So you have country, population growth, Gini, life expectancy, infant mortality rate. So there are few variables which is added: health expenditure, GDP, expected years of schooling, mean years of schooling, education index. By default, it has come as the scale. If you really want to change, you just double click and change the category, whichever the category you want, whether you want to put it as ordinal or nominal. According to the variable, you can change and you just click. If you want to go to the next variable, click here, next variable, next variable, next variable, and click on the top. So all these variables are now right here. Hope it's very clear. Now, what is the first thing is, as you know, any data sheet, when you import a file in the software, the first thing is we have to check the descriptive statistics. So as you know, why we check the descriptive statistics, we want to see whether the data set is normally distributed. If it is normally distributed, then we have to write and report mean and standard deviation. If it is not normally distributed, then we may have to report median value. All those things we have to check, and whether there is any outlier, it is there. All those things we have to check. Therefore, we actually do descriptive statistics. We check, then only we go for an inferential statistics, right? First, we will see how the data look like. But is there an outlier? Is there any extreme values? We will check. So what you have to do is you have to just click analysis. Okay. And when you click analysis, I don't think in your software may all these options will be there, like SEM, R, MAJOR, StatCat. All these options may not be there. I have all these options because I have in the library I have added these options. Therefore, it is visible in Jamovi software. You may have up to factor I fill, frequency, regression, ANOVA, t-test, exploration. So if you really want to see the descriptive statistics, just click on exploration and click descriptives. Okay, descriptives. The moment you click the descriptives, you can see here you have the descriptive variable one side, another side the results, and at the same time you will get the references. These references can be used. Usually they ask which software you have used and what is the output, give the output. No, all those things they ask, right, for the publication. You can actually copy this references for your research. Now let us take, I want to check the descriptive statistics. Since it is in continuous, I will select GDP as a variable. So I've selected GDP as a variable. So all the clarity it is given, by default it will come, whether you select or don't select, by default N will be there, missing value will be there, mean, median, standard deviation, minimum and maximum numbers will be there. Now, if you're not happy with this column wise, you have to just click on descriptive. There is option variables across columns, right? There is option called variables across rows. Just click on rows. Automatically, whatever the values which was there in the column, it will become row. So whatever I mentioned, that has become row. There is also option here, frequency tables. Let us take your variables are in nominal or ordinal form. Okay, if your variables are a nominal ordinal form, then if you click this option, it will show each category what is the number of frequencies. Category wise, it will show the frequencies. Now, it cannot be used. The best part is it will actually show you which variable should be inserted. In SPSS, sometimes it will not be shown, but here it will show. For example, here split by. Can you see here? It is actually telling like only categorical variable you can insert here. Continuous variable cannot come. So here you can see only nominal and ordinal can come. No scale variables. So even if you click also, it will not come. If you use the categorical variable, it will show. Then you click on statistics. What are the statistics are available? By default, as I said, sample size, missing value, mean, median, all these no, by default it will be there. And if you really want to check the normality, just click on normality check. Okay, and you will have Shapiro-Wilks normality value, where you are having p-value which is 0.001, which clearly says that the data set is not normally distributed. Correct? So it's very clear indication the data set is not normally distributed. So now the question is why it is not normally distributed. If you really want to check, you can click on outlier, just click on outlier, and it will show you the highest outlier and the lowest outlier, which is the lowest point, highest point. And row wise it will show, row number wise it will show, values it will show. Can you see the highest outlier 72, which is having 1,14,482, right? So which is having a highest number. So you can either delete or you can hide the number. So you have an option, right? So you can actually do it. You can actually do it. So lowest also you have. Then in case if you are not happy with that, like no, and you really want to see graphically you really want to see, then you can actually click on box plot. What is an advantage of box plot is it will actually show you graphical representation, which are the extreme outliers. And you can see here 72 and 57 is extreme outliers. And if you know that 72 and 57 is an outlier, just go to the data and 72 row. Just click data, 72 row. You can see here 72 row. And if you feel that you want to delete it, you can actually delete that as an outlier. If you delete that, let us take, I will delete this. Let me, okay, so 72, if I delete, 72, if I delete, and it will not be there at all. See, and so suddenly you will also see some kind of a reflection in the numbers. And if you really want to delete 57, 57 also can be deleted. Delete is not a right option, but then for the sake of understanding, those who are understanding for them. And in this box plot, you can see the first, it will represent the 25%, and the next 25% from the middle point to this, the next 25%, and the extreme end it is 100%. So this is the 25, 4 quartiles, first quartile, second quartile, and third quartile. If you really do, by mistakenly, if you have deleted, if you want the number back, just click on Control Z. So you'll be getting the number. So it's a very good software. Looking at the number only, you can actually delete or you can hide as well. Now, let us take, you really want to see the analysis. Now, the result, this extreme value ka analysis you want to see, the same dashboard you want to see. In SPSS, what used to happen, you have to go again, analysis, you have to click. So it's here nothing, you just click on the value. On the top of the table, you click, automatically what you have done, it will come, right? So let us take, if I click on data, and suddenly if I want to see the descriptive analysis, just click on descriptive analysis, what you have done, it will come. Same way, you can actually select other variables as well. So have a selected health expenditure, I can select health expenditure. So automatically all the values will come, right? Here in the health expenditure, you can see 134 is an outlier, which represents in the box plot. And some believe in QQ plots, you can actually click on QQ plots also just to check the outlier. And you can see 134. This is a 134, which is far away from the line, which all other values are closer to the line. And if you really want to see a violin curve, then you can also click on violin curve and you can see the values are away from the violin curve and all the data sets are inside, and 134, which is away. If you want to see the bar plots, then you can also see the bar plots. So you have all these options, which is there in the descriptive statistics. Okay, so this is the one set of information. Now, let us also understand why we have to check all those things, because if you really want to do an analysis, these all options are actually available. Now, let us understand first, before going to the chi-square test, let us understand what is chi-square test. Chi-square test is a test which is actually used to find the association between the two variables. Okay, two variables. It is a categorical. The first thing is we have to understand, we don't apply chi-square for the continuous variable. Okay, the first rule, the thumb rule itself is, if we really want to apply chi-square, we have to, the variable has to be in categorical form. So what do you mean by categorical? Usually we get confused with like income. Sometimes income will be in the form of scale. Sometimes income will be form of categorical as well, right? So the very simple understanding of understanding categorical is researcher asks a question, and if the question is where the respondents, if they are writing a number, let us take open number. If a researcher is asking what's income and the respondents is writing 1,50,000, 45,000, 25,000, goes on, that becomes a scale. But researcher asks a question on income and he gives the options for that question, income, and 4 options, 10,000 to 20,000, 25,000 to 35,000, or 35,000 to 45,000. When he gives an option, that becomes a category. So whenever a variable which is having the options for that particular question, it becomes a categorical. And whenever the variable is having an open such question where it is measured in a scale, it becomes a scale. In our example, we are going to take one objective, that is to find out the association between health insurance awareness and social demographic factors. Awareness on health insurance, it's a categorical variable where the dependent variable, like no, it is yes or no. Okay, we have 2 options, yes, no. And we also have other social demographic factors. Social demographic factors like area, household size, elderly size, occupation, healthcare, right? Primary health center, self-rated, SE, level of income, household savings, it goes on. So you have. So usually to apply chi-square, we have to identify which is a dependent, which is an independent variable. So we know that we are going to compare with one variable, that is health insurance, with all other factors, right? So all other factors will become independent variable, and the variable which you really want to compare, that becomes the dependent. So in our example, health insurance, yes or no will become a dependent, and all other variables will become independent. All other variables will become independent. So you have 2 options like this. So let us go with our example in Jamovi. So what we are going to do is we are going to open a file. Okay, we are going to open a file, which is file name is chi-square, right? File name is chi-square. So this is a chi-square variable. So we have to first, what you have to do is, once the variable comes into the Jamovi software, we have to check whether the variables are in the proper form. So let us take the first variable, health insurance. Health insurance, which is the nominal, and it is in the text. Okay, fine. Next one, area, which is a nominal, which is in the form of text. Fine. Next one, occupation, which is a nominal, which is in the form of text. Okay. Next one, total household savings, which is a nominal, which is in the form of text. Fine. Next one, household debt, which is in nominal, which is in the form of text. Okay. Social economic status, which is in the nominal, again, it is in the form of text. Then availability of hospital, which is in nominal, which is in the text. Fine. Availability of primary health center, nominal, which is in the form of text. Self-rating health, okay, whether they are rating themselves, whether they are good, poor, excellent, they are just rating themselves, which is in the nominal, which is in the form of text. Level of income, which is in the nominal, again, text. Then household size, nominal and text. Then elderly size, nominal, text. Total communicable diseases, total non-communicable diseases. Okay, so we have all these variables. So it's ready now. Okay, yeah. Am I audible?
Yes, sir.
Okay, fine. The next thing is what we are supposed to do is we have to find out chi-square, right? So for that, you have to just click on frequencies, okay, frequencies. And there is an option called chi-square test of association independent no sample. So there is an option called chi-square test of association. I'm just taking one example how to do it. There are various analysis. I'm just taking one example. Okay. So just click on chi-square test of association. Click chi-square test of association. Okay. And as I said, no, there will be one variable which you have to take it as a column, and there are other variables which you have to take it as a row. So in our example, which we have to take it as a column, which is a dependent variable, which we have to take it as a column. All are there?
Yes, sir.
Which we have to take it as a column. We have to take health
insurance, the
insurance.
dependent
Correct,
variable.
correct. Health insurance, yes or no, as a column. The moment you take health insurance, you can see a difference. Here you can see on the top health insurance. Now you can take any variables which you really want to take it as a row. Okay, it is a 2 cross 2 or 3 cross 2, 4 cross 2, you can go on. So for our example, what I will do is I will just take occupation as a no as a variable to the row. Okay, I'll just take as a variable to the row. Fine. So now you have, when you take occupation as row and when you take health insurance as column, you can see the numbers, right? So again, occupation I've taken as agriculture, any other daily wages, employed. So you can see out of 161, how many yes, how many no, you will see. In chi-square test, it's very important. We have to see the expected cell count. The moment you click, chi-square value will come, right? So you have got the value 0.910, right? It's perfectly fine. But it's also very important. We have to check the expected cell count. We check expected cell count only when the tables are 2 cross 2. Okay, tables are 2 cross 2. If the expected cell count is less than 5, we'll be using a value called Fisher's exact test. Okay, we will not be using chi-square test. We'll be using a value called Fisher's exact test if the tables are 2 cross 2 only. If it is 4 cross 2, we'll be using the same value. In our example, you can see it is 0.910 and you have a statistics here. And if you click the statistics, by default, there is a chi-square value. Okay. Okay, by default, there is a chi-square value. Before statistics, if you really want to see the expected counts, you just click on expected counts and you will see expected count. This is a cell, 4 cell, which is having the expected cell count, which is less than 5. Okay, other all cells are having above 5. Let us take here. This cell is having above 5, above 5, above 5, above 5, above 5. But there is one no cell which is having agriculture and no, which is having a cell which is having expected cell count less than 5. But not a problem. You can actually use the value, not an issue at all. You can use the p-value, you can use the chi-square value. But only thing is, if the 2 cross 2 table comes and if there is expected cell count, if it is less than 5, we'll be using Fisher exact value. Now, if you really don't want expected cell count value, now for understanding only, we have to click expected cell count value, just click expected cell count value. And if you really want the values percentage should be shown in the row wise, you can actually show it in the row wise. Otherwise, you can also show it in the column wise as well. So percentage you can actually show, right? Then in the statistics also, you have chi-square value. Okay, you also have chi-square continuity correction, which is usually used for the samples. If the sample size is only 40, we actually use a chi-square continuity correction. And also you have one more test called Fisher's exact test, which is actually used when the tables are 2 cross 2, tables are 2 cross 2, and expected cell count is less than 5. We click the Fisher exact test. And if I click the Fisher exact test, you can see Fisher exact test is 0.921. But this value and 0.910, there is a difference. But this value will not be taken because table is not 2 cross 2. Therefore, Fisher exact test, you need not to worry at all. Then also you have, there is also a option called Cramer's V. Okay, phi and Cramer's V, which you can see 0.05. What is the rule when we have to apply chi-square? I have seen many a times people just take the variables and do the analysis. When we have to do chi-square, only when the Cramer's V value is above 0.50. What is 0.50? The Cramer's V and phi and Cramer's V, that represents the strength of the association. Okay, how strong these two variables are, how strong this occupation and health insurance variables are. If the strength of the association is less than 0.50, that means it is weak. So we can't take that particular variable for the chi-square test. Okay, if the strength of the association is above 0.50, then only most of the time we'll be taking those variables for the analysis, that is for the chi-square test. So you have all these ideas. So that is one thing, and you can see here Cramer's V value is 0.05, which clearly indicates that the strength, though you are having p-value 0.91, and you're saying that there is an association, you are rejecting the null hypothesis, there is no association, there is an association you are saying, but the strength of the association is very weak. Though you say there is an association, but the strength is really weak. Okay, so, and also you can actually plot these things, and if you click on bar plot, you will see a bar plot here. And if you want counts on y-axis, you can take the counts. If you want it in percentage, you can click on percentage. It will pop up in percentage. If you really want it in column, within column percentage, within row percentage, you can select. But usually total is better. And here also x-axis, you can actually select. Okay. Then bar type you can select, side by side or stacked also you can actually select. Okay, so you have all these options just to see before going to the Excel and doing some diagrams, just to see how it will look like. You can actually see in this one. So this is one thing. Okay, so let me remove this occupation and let me take one more variable. I will take area. Area, you have urban and rural, and let me check the expected value here. Expected value, surely it will be more than that. And let me check level of income, socioeconomic status. Okay, so here also you can see the values are above 5, expected 5. So there is no point in clicking Fisher exact test. Even if we click Fisher exact test, 0.821. So Fisher exact test is only applicable when the tables are 2 cross 2 and expected cell count is less than 5. We'll be writing Fisher exact test to p-value, and the value of the Fisher exact test will remain the same. Okay, so chi-square contingency correction if the sample size is 40. So this is about the categorical variable. Okay, now let us also understand one more Excel sheet that I have shared, which is actually of a regression. Just click on HDI final. Okay, just click on HDI final. Okay, so you have here final HDI file. So we are going to do a regression analysis here. So what basically we'll do is first we will understand what is regression analysis in Jamovi. Regression, there are simple linear regression models are there. Another one is multiple linear regression model. But to run the model, we have to check the assumptions. There are so many assumptions. In that, main assumptions are normality, you have to check, homoscedasticity, you have to check, autocorrelation, you have to check, multicollinearity, you have to check. So you have to check all these assumptions. If it works out, then you can actually go for a regression analysis. Theoretically, I have just explained you, but practically I will show, and I will also show you how to go about it, right? So in regression analysis, since it is regression, you have an option here, regression, right? You have an option regression. So just click on regression, right? The moment you click on regression, there will be so many options. What is the primary objective, like the primary thumb rule of regression is, before going for a regression, we should see all the independent variables with dependent variable. Is there any correlation? If the correlation is above 0.70, then only we take for a regression. So therefore, the first option itself is correlation metrics. Okay. So first thing is independent variables and dependent variable. We will just see the correlation. If the correlation is above 0.70, then we will go for a regression. So the first option is correlation, but I will directly skip that step and directly click on linear regression. Okay, in this, we have to select the dependent and independent variables. Okay, we have to select dependent and independent variables. So whatever the data set you're having, okay, if you observe the data set, we are having so many informations here, population growth you have, Gini you have, right? So what we are going to do is we are going to predict life expectancy. Okay, we are going to measure the life expectancy using other all independent variables. So population growth will become independent variable. Gini is a variable which represents income inequality. Then life expectancy, okay, which is a dependent variable. We are going to check life expectancy, and also infant mortality rate will go as independent variable. Health expenditure will go as independent variable. GDP will go as independent variable. Expected years of schooling will go as independent variable. Mean years of schooling, it will go as independent variable. Education index is a combination of expected years of schooling and mean years of schooling, that will go as independent variables. So all these variables will go as a independent variables. Now, by default, you can see in the linear regression, what are the values will come. The moment I select the dependent variable and the independent variables, all these values will come, whether you select or not. So I will select the dependent variable as life expectancy, and I will select all the independent variables. Okay, I will select all the independent variables except expected years of schooling. I will select and I will put it under covariates. And you can see dependent variable, only the scale will go because you have selected linear regression. Dependent variable, only scale value will go. Covariates, independent variables, only, it will go scale value only. In case if you have a categorical variable, we call it as a dummy variable. Okay, in case if you have a categorical variable and if you really want to run a model in a multiple regression model, then you have to put that particular variable in the factors. You can see the factors. And in case if you have a weighted least square method, you might have heard weighted least square method, which is there in SPSS. There is an option, okay, where you can put the weight. That also you have your weight manually, you have to calculate and you have to put the weight here. That particular variable, you can put it here. Now you have model fit value. You can see R value. Okay, you can also see the R square value, goodness of fit. Goodness of fit is 0.909. That represents 90.9% variation. All these independent variables can explain the dependent variable. Only unexplained is only 10%. 91%, close to 91%. All these independent variables can explain the dependent variables. Only 9%, close to 9%. We could not able to find in this model, which has remained as the unexplained. Now, what is the problem? Most of the time in what happens in SPSs, we have to understand. For a person who's not from a statistical background, he has to understand the theory and he has to check. But here you have a separate row called assumption check. You just click on assumption check. Whatever the theoretical I have explained, which is there. The first thing is we want to check the normality. You just click on normality, you will get the normality. Normality check values you will get, Shapiro value you will get, right? So you're going whether it is normally distributed or not, you will be getting, right? So the data set is normally distributed, right? You're accepting the hypothesis data set is normally distributed, and also along with that, the whether data set is heteroscedastic or not. right? There is a two things. One is homoscedastic, another one is heteroscedastic. Whether the data set is heteroscedastic or not, again, you can see here, we usually take the value of Bruch-Pragen test, which is 0.241, which clearly indicates that the data set is homoscedastic. If it is heteroscedastic, then we have to convert the data set from heteroscedastic to homoscedastic. So you have two normalities. The moment of clicking on one click, you will get the result. Then what is the next assumption check? We have to check the autocorrelation. Just click on autocorrelation. When you click on autocorrelation, you will get the value. W Watson test is 1.79, and this clearly indicates 0.204. P-value is 0.204, means you are saying that there is no autocorrelation. Null hypothesis, there is no autocorrelation. Alternative, there is an autocorrelation. So that means you're going to accept saying that there is no autocorrelation. So again, first assumption is clarified, and next assumption is also it is okay for you. Then you also have to, if you really want to check residual plot, you can actually see the residual plots, how it looks like right now, whether is there any scattered, whether is there any problem, you can actually look like, because the expected value of the residual should be 0. So it sounds good, so not a problem. But also you have to check the collinearity statistics. What is the rule of the collinearity statistics? The variance inflationary factor should not be more than 10, right? If there is more than 10, that means that particular variable I have to remove, right? Here you can see variance inflationary factor is mean years of schooling and education index, which is about 10. So if that is the case, then I have to remove one variable. Then only I can take this forward, this particular variable forward. So what I will do is, the maximum value is 17.56. So what I will do is I will just remove the education index 17.56. The moment I remove 17.56, automatically you can see here VIF, all the values are less than 10. And I will also see this is W Watson is proper, and also see Butch pattern is no problem. Then I will also see there are few variables which is significant. Infant mortality rate and GDP is significant. These are the two variables which is significant than the other variables. And also goodness of fit value 0.907. And when more than one independent variable, now model, you can see there are many independent variables are there. So when there is more than one independent variable, we take adjusted R square value. Okay, adjusted R square value. So you have to select, you have to just click model fit, and you just click on adjusted R square value, which will show 0.903, so close to the value. So we report most of the time adjusted R square value, which will adjust with the number of variables and the parameters with the sample, and it will give the number. So this way we can actually do the regression analysis. The best part is the assumption. The next thing is, if you really want to save some variables in SPSS, what happens? They have given like standardized error, unstandardized error, standardized residuals, unstandardized residuals. So all these things are there. Sometimes it will be very difficult for us to, which is a predicted value. A person who teaches will know actually it is unstandardized value is a predicted value. The chances are there sometimes they may take standardized value as a predicted value. Here there is no confusion at all. If you really want a predicted value of this model, you can click on that. If you really want the residual value of that, you can click on that. If you really want to see the each value's Cook's distance, because Cook's distance, each observation should not be more than one. If it is more than one, that particular row you can delete. That itself will create an outlier problem. So if I click this, all three values have come. If I click on data, you can see predicted value has come, residual has come, Cook distance, it has come. I don't think any value is above 1. So you will have three options: predicted, residuals, and Cook's distance. So this is how we can actually do the analysis. Now, when it comes to the extension, right? Extension. Now we are going to do with meta-analysis. So for the meta-analysis, you need an extension called MAJOR. Okay, MAJOR. Okay, so what you have to do is, there is a 3 dot. Can you see on the extreme right, there is a 3 dot. Okay, icon. Just click on that. Sorry. Okay. Okay, there is a, can you see on the modules, can you see modules on the extreme right? Just click on that. And there's option called Jamovie Library. Okay, just click on Jamovie Library and you have options like installed, available, and side load. Okay, so you have installed. So these are the no tools, these are the add-ons which I have installed, which I felt that it is important for me. There are so many statistical analysis which I may not be knowing. When I learn, then surely I will add as an extension. So whenever you learn something, better to add that as an extension. So what you can do is you just type as MAJOR, MAJOR. So you will be getting like this in available option. See, I have already installed, therefore it is coming here. But please check in available option. You will be getting this meta analysis for Jamovie, and please install it because it's an interface for Jamovie, our package meta for no analysis. So you please install this. There is option called install. For me, there is two options, hide or remove. Okay, these are the two options. These are the two options. Okay. So it is just you have to install. Okay. So once you install it, it automatically it will come here as a MAJOR. So it comes here. So you just click on MAJOR and you have an option called what data set I have sent. There is an option that is mean differences. Okay. Mean differences. That is option. There are different like correlation coefficient, dichotomous models, effect size models, proportion, reliability. But one data set which I have sent you, which we are going to deal. Okay. So what you have to do is you just open the file of meta-analysis. Hope you are having the file which I have sent you. Just click that meta-analysis file. Okay. And once meta-analysis file is come, you have to change the category, that is measure type, which you have to change it to continuous. Okay. Here also you have to change it to continuous. Next one, continuous. Next one, this also continuous. Okay. This also continuous. And this also continuous. So what I have done is it's a study, basically health insurance, rural and urban, where you have a study respondents and you have a sample size, how many like no rural and how many urban the study has been done, and what is a mean health expenditure and standard deviation, and also in urban area, what is the 225, what is the mean and standard deviation. Meta-analysis first is systematic review we have to do, then whichever the common studies that we are having based on the tabular form we have to put it, then only we can take it to the software. So MAJOR, you just click, since it is in the form of sample size, mean, standard deviation of two groups, click that. Okay, then here the first thing is you have to add the study. Just you click the study, and the first is sample size, group one sample size, click group one sample size, group one mean, group one standard deviation, group two sample size, group two mean, and standard deviation. Okay. Am I audible? I think somebody's. Yeah. So once it's done, you can see here the interpretation and also diamond shape curve. You will see the forest plot. You will also see the funnel plot. Okay. You can also see the funnel plot. This is just I'm showing how Jamovie is helping to do the analysis. There are limitations. There are certain things, certain analysis cannot be done, but separate, separate, I can continue.
Yes, sir.
Yeah. So separate it can be done. So this is how the interpretation also will come in, and all these, information, what is effect size, what exactly can be done, and all those things. So I'm not.
Sir, please unmute yourself. Preji sir, am I audible? Sir,
Ma'am, am I audible?
yes, now you are audible, sir.
Okay. Shall I continue?
Yes, sir. Please, sir.
Okay, so this is how it is, but in detail, I'm not going already. It's 2:51. I just want to stick on time, stick to the time. Now the point is, one is a meta-analysis over. So what are the other extensions which is available? Now there is also an extension called StatCat. Okay, just type here StatCat, StatCat. Again, it will be available in available, not in install. I have already installed. So method selection tool. You can see here method selection tool. So here this will come. Okay, so if you install, it will come in the software. So once it comes in the software at the extreme end, it's the extreme end, you can see here StatCat. Okay, just click on StatCat and there are three options: single variable, relationship, repeated measures. Okay, now let us take, there is a data set. You feel that it comes under correlation, it comes under prediction, it comes under group comparison, then you select the second option. Okay, so select the second option. If you feel that it is a single variable, select that variable. Now, sorry, let me take some other data set. Okay, StatCat. Okay. So now let me take as life expectancy as a dependent variable, and let me take health expenditure as an independent variable. The Jamovi will tell you which analysis is the best analysis for your research. Okay, again, you may have to consult statistician, but a software will tell you which analysis is the best for your research. Now, when I've taken life expectancy and independent variable health expenditure, Jamovi is actually telling linear regression analysis, I can run it. Okay, and also Pearson correlation coefficient. Now, if I click on linear regression analysis, it will actually take you understand what exactly is linear regression analysis, what is regression, what are the assumptions, how to write the hypothesis, right? What are the formulas are being used? Everything clarity you will get in this, right? So now again, if you really want to practice question, you can actually just click practice question, practice, and you can select the topic and you can actually understand with the questions, you can actually understand the subject. Right, there are so many set of concepts which has been there, and you just click and you can actually understand the subject. Okay, this is one thing. And the second thing is again StatCat. If you click on StatCat, if it is a single variable, you just click on single variable, and which variable, life expectancy, select life expectancy, and it will actually tell you what test, one sample t-test. Okay, Wilcoxon sign rank test can be applied, or non-parametric, otherwise one sample t-test, right? So it will actually tell you what kind of a test you can actually apply. So StatCat is another option. So one more tool which is there in the library, which is a Jamovi library. Again, you have to just type LSJ. Okay, what is LSJ? Learning statistics with Jamovi. Okay, learning statistics with Jamovi. So what exactly the best part of this? You just click learning statistics with Jamovi here, option. Okay, learning statistics with Jamovi, and it gives you a full book. Like how our library may you have a book, same way you have a full book here, and just click here, read for free, and you will have all the analysis. If you really want to know statistical tools, you can click on statistical tools. And if you want to understand some other factor analysis, just click on factor analysis, and it will tell you how you have to put the component, item, what should be the score, uniqueness, all those things. It will, what to do with the reverse scale, how you have to put everything. It will actually guide you. It will tell you what you're supposed to do. So you can actually learn with the help of statistician also, but at the same time, whatever you do, make sure that you actually show it to the statistician once, because anyways, the software is giving result, but it has to be confirmed whether the same numbers are, whatever results you have got, it is same or not. So this is about, in nutshell, I have just covered, Jamovi. If you for those who really want to learn, and if any result, if you want it in a syntax form, there is a 3 dot. In the 3 dot, may you just click on syntax mode. If you click on syntax mode, can you see statcat single? Can you see here? So if I remove this, syntax will go on. So if I really want certain results in coding in a syntax form, how we have got the result, you just click here, you will get the result. So these are the options which is actually available. I have 4 more minutes. Correct, no?
Yes, sir.
Yeah. So the next tool which we are going to discuss on is, the tool name is actually Accio, right? So tool name is Accio. Okay. So can you see this tool?
Yes, sir.
Yeah. The spelling is Akkio. Akkio. Okay. Accio. Now, in this, what basically, if you're really interested in prediction, if you really want to clean the data, if you want to merge that labels and all, you can actually use this table. How to upload this is, you have to click here, new project. Just click on new project. And then you can upload a file. You just click on upload a file, and Excel sheet, whatever. Ours is in Excel. Just upload data set, and you can actually upload the file. Okay, you can upload the file. So once you upload the file, so you will be getting a data set. Okay, you'll be getting a data set. Okay, like this. Okay, your entire data set will look like this. Okay, your entire data set will look like this. Okay, so you have SDI where it clearly shows 139 rows. Extreme left, you can see 10 columns and country, population growth, and everything. And you can actually change your text number, whatever you want to change, you can change. And if you really want to drag this, the country wise, you can drag. Then all those things, all the data informations are available. Okay. So now, same as population growth, Gini, life expectancy, infant mortality rate, it goes on. Okay. And also, if you really want to do type here, you can, there is a question, there is a chat box where you can type, what do you want to do with your data set? You can actually type and what basically you want. If you want a correlation value, if you want something, you can actually type. Okay. Then if you really want to clean the data set, just click on clean. And there is option like standardized data columns, remove unexpected nulls, replace excess categories with others, remove constant columns, all those things. It will flag outliers. So all these things, if I click on preview, and it will clear and it will give. So you have cleaning option. You can also merge the 2 columns. Let us say you have 2 files and you really want to merge the 2 columns. You upload the file and you can actually merge the cell as well. And if you really want to generate the dashboard, you just generate, you can actually type for this data set. I'm not doing for this data set, you can actually type as generate a correlation between life expectancy and population growth, and just click a generate report. It will show different diagrams. It will show just in type only, you will get different diagrams, bar diagram, plot diagram, you will see, and you can actually see. At the same time, you can also review the table, like how many unique rows are there, values are there, and how many empty rows are there, and what is the data type. So you can see 139 different numbers, 139 different numbers, 111 only. Out of 139, there were a few numbers which was repeated. So it's very easy if any kind of a data manipulation or same number, if you are using to get more sample size and all, with this, they can actually figure it out, whether the numbers are different, whether it is the same, all those things they can, what is the percentage of same number, everything can be identified with this one column. Okay, then once the preparation is done, the next one is the explore. And in this explore, you can actually ask the questions like what you want. So show a scatter plot of life expectancy versus GDP, compare health expenditure and life expectancy, visualize IMR across different countries. Whatever the chat you want, you can actually type and it will actually pop up. The next one is the predict. Okay, predict. In this predict, there are two options. One is predict, another one is forecast. If you really want to predict, a time is not required, but if you really want to forecast, time component is very, very important. So dependent model time is what is that called, forecast is required. So if you really want to predict, you can predict. Now we were predicting life expectancy. Okay, I wanted to predict life expectancy. If you really want to ignore some of the variables in prediction, you can ignore expected years of schooling, mean years of schooling, education index. You want to really ignore those three variables to predict, and just click on creative predictive model, and it will use all the neural networks, or then all the evaluating models. All these models will be used, and it takes minimum 40 seconds. Okay, so all these networking will be used, and it will load it, and it will give the analysis, what is the life expectancy with respect to the statistics, with respect to the machine learning. Okay, so that is something that you can see. At the same time, if you really want to generate the entire report, and if you want to put it in the dashboard, just click on report, and whatever the report is generated in the predictive model, that will come in dashboard. That will come in dashboard. So it's taking some time. Am I audible?
Yes,
Yes,
sir.
sir.
So you have here then accuracy, plus or minus, life expectancy, median life expectancy. You can click here, add to the report, and it will come here report option. You might have seen there is an option called report. Okay, there it will come. Then you have all the top fields, then top factors, then all these informations it will generate: high life expectancy, median life expectancy, low life expectancy. It has categorized average value of infant mortality rate, average value of this one gross domestic product, average value of Gini value, segment rate. It has been right, sample row, how many it has taken. And if you really want to reduce this, if you reduce the sample size, what will be the life expectancy? If you increase the sample size, what will be the life expectancy? If you increase again, what will be the life expectancy? So you keep on increasing the sample size, what will happens to the life expectancy, you can actually see. And at last it comes reports, where you can actually add. So if you really want to expand the insights, all the entire thing, whatever you have done, you really want to see in one click. So that also option is available, which you have to click on no. So you have all these options where you can actually see. Okay. Yeah. So, madam, should I continue or?
Sir, I want you to continue, but with the time and all.
Yeah.
Yeah.
Okay, ma'am. Thank you.
Thank you so much, sir. So thank you so much, sir, for this wonderful session. I hope it was a very insightful session for all the participants, where we learned about a very new tools, that is Jamovi, and its application, that how can we do the data analysis through different tools. And also we know about at last the Accio. Now, the session is open to all the participants for query. If anybody have any query, they can ask.
Hello, sir.
Yeah.
I have one small doubt. When we tested with chi-square, we have used one dependent and one independent variable. Will it be possible to add on more independent, or should we test one by one?
Ma'am, it is, did you check, ma'am, just now?
Yes, sir.
It
I
is
was
showing
doing.
one only, right?
Yeah, sir.
Yeah, it's possible only one, because one by one we have to check, ma'am.
Okay, sir.
So I have just one question for the meta-analysis, that when we are performing the meta-analysis, what are the assumptions and the limitations that we have to be careful while performing the analysis, sir?
Ma'am, I have not gone to the theory part. I've just shown you how we can do it.
Okay.
Meta-analysis itself is a topic. It takes a lot of time. Like,
Yeah.
no, we have to, there are assumptions are there. And before going to the meta-analysis, the first thing is a review. Then it goes as a systematic review. Then we have to segregate, and based on that, we have to go for a meta-analysis. So maybe one session we can think of in the future on meta-analysis, because
Sure, sir.
itself is a vast topic, how to do it systematic.
Sure, sir. Thank you.
Anybody else? Okay. Participants, already the feedback form is there in the chat box. Fill it up. So we have come to an end of this enriching faculty development program. On behalf of the organizing committee, I would like to extend the heartfelt thank you to our today's speaker and all other speakers for sharing their expertise, and also to all participants for their active engagement. So before we conclude, we kindly request you all to fill out the feedback form. It is there in the chat box, and the certificate will be shared through mail within a week. Thank you once again. Thank you for all for being a part of this faculty development program. Let's continue the journey of learning and innovation. Have a great day ahead. Thank you so much, sir.
Thank you, ma'am. Thank you so much.
Thank you so much, Reggie, sir. Thank you.
Thank you, ma'am.